Paul Ehrlich was one of the first molecular thinkers at the beginning of immunology. He proposed that the antitoxins discovered at 1890 inhibit bacterial toxins via their specific binding. But how are these antitoxins produced? Paul Ehrlich described side chains on the cell surface. When the cell is exposed to a toxin, it produces these molecules that are released as soluble antibodies into the serum. Only in 1960 were membrane-bound antibodies found. They are part of the B-cell antigen receptor, or BCR. In 1989, two signaling subunits, Ig-alpha and Ig-beta, of this receptor were discovered. Today, what do we know about how antibodies are produced during an infection or after immunization? Antibodies are produced by white blood cells of the immune system, called B cells. Each B cell carries antigen receptors with a unique binding specificity. If a foreign substance, like a virus, enters our body, only a few B cells recognize the so-called antigen. It binds to the receptor and activates the B cells. The cells become antibody-producing plasma cells. How does the antigen interact with the BCR? Let's have a closer look at the surface of a B cell. There are up to 120,000 BCR antigen receptors on a single B cell. These receptors are pre-organized in groups, also called oligomers. If an antigen binds to the BCR, the receptor groups are disturbed and open up. This activates the B cell. But how is the signal of an antigen binding to the receptor transmitted inside the cell? Let's have a closer look at the process of activation. To transmit a signal, the BCR interacts with the protein spleen tyrosine kinase, SYK, located inside the B cell. This kinase cannot phosphorylate and bind the closed receptor group. Only once the antigen opens the BCR oligomer can SYK phosphorylate and bind the tails of the BCR signaling subunits. The complexes now move around in the membrane and phosphorylate neighboring BCR oligomers. Further SYK molecules bind to neighboring BCR oligomers and open them from the inside. In this way, it only takes a few antigen molecules to activate large numbers of receptors. The signal is amplified and results in the full activation of B cells for antibody production, as suggested by the dissociation activation model.